So maybe now we give the floor to Bruno Dorin. For French people, je voulais expliquer simplement qu'aujourd'hui on lance Agrimonde en anglais. Le livre avait été publié en français il y a quelques mois et que si on s'exerce à parler anglais maladroitement, mais on essaye de faire ce qu'on peut, c'est bien pour toucher un public qu'on ne touche pas d'habitude. So, welcome to our English-speaking colleagues, because today we did a very special exercise for us. As you remark, we are not fluent, but we made an effort so that we reach some people we wouldn't reach usually. So I give the floor to Bruno Dorin, that is one of the experts that signed the book.
Good morning, and as far as I'm concerned, I don't have an accent from France, but from India. I had the chance to live for some years. I hope you will enjoy it. So, as Patrick said, Agrimonde is a foresight exercise where we try to imagine different possible states of food and agriculture in 2050 in order to better understand and debate where we would like to go in the future and how. It's a brainstorming exercise, a forum for discussion, whose primary ambition is not to answer questions, but to rise, share, and debate what we hope are good questions, both for our research institution and the rest of the society. Agrimonde is a three-component platform, a think tank debating some scenarios with a quantitative tool and the expertise of its member. As far as the think tank is concerned, it gathered experts from different fields and institutions. These experts met almost once a month for more than 2 years in Paris or Montpellier. As far as the scenarios are concerned, we choose to work on our only 2 in number, while we could have explored many other ones. These scenarios show 2 very different views on the future. We call them Agrimonde 1 and Agrimonde Geo. In the second part of this talk, Sandrine will present you these scenarios and what we learned from them. As far as the quantitative tool is concerned, its name is Agribiome. Agribiome was designed for analyzing and debating past and future production, trade, and distribution of food biomass from a single country to the whole world. It's not an economic model. With Agribiome, you give your assumption on consumption, yield, crop areas, etc., and it tells you if there is a global equilibrium between all regional supplies of edible biomass and their use as food, feed, seed, agrofuel, etc. This equilibrium is in calories. The use of this unit led us to convert and aggregate in calories millions of data from the FAO. In other words, the estimates in calories that you will see in this presentation and in the book are unique. Let's go now to the heart of the subject. Before exploring the future, it was important for the Agrimonde team to first review the past together and worldwide. We worked at the scale of the 6 regions delineated by the Millennium Ecosystem Assessments: Sub-Saharan Africa, Asia, former Soviet Union, Latin America, Middle East and North Africa, and OECD's countries as in 1990. With 3 graphics only, I will try to show you progresses but also growing disparities amongst regions since the beginning of what we can call the modernization of agriculture. Since the 60s, the world population doubled, but the average per capita of food calories increased from 2,500 to 3,000 kilocalories. It's really an amazing accomplishment, hard to believe 50 years ago. As you know, it did not solve under and malnutrition, but the Malthusian prediction proved to be wrong. Science and technology really help to eradicate large-scale famines. Cheap oil too. for processing fertilizer and pesticides, pumping water, making and using roads, tractors, and combine harvesters, transporting inputs and food, etc. This first graph shows how has increased the production of plant food calories per hectare. Tremendously in Asia, as you can see, from less than 10,000 kilocalories a day in 1961 to more than 25,000 today. This green revolution combined high-yielding seeds for a few plant species with massive use of fertilizer and irrigation. Irrigation helped not only to increase crop yield, but also the number of crops per year. But second important point, unlike in OECD, the chemicalization of agriculture with fertilizer and pesticides was not accompanied by a motorization with tractor and combine harvester. Yeah. Lost my line. And combine harvester. In Asia, in Asia, it would have taken the job of 100 million of poor farmers and pushed them into urban shanty towns that are already crowded. Motorization of agriculture is a key variable to understand the striking difference between OECD agriculture and the rest of the world. Today, in OECD, each farmer produces every day more than 400 kilocalories. It goes beyond 1.6 million in North America, while this figure is below 12,000 in Asia and Africa. And in Asia and Africa, we have now 1 billion farmers working with less than 1 hectare on average. This second graph shows you the net trade balances of plant food calories, how these net trade balances evolved over 50 years. You see rather clearly growing surpluses of food calories in Latin America, OECD, and former Soviet Union, and growing deficits in other regions. I will comment this graph by just saying that despite a boom of food trade clearing surpluses and filling some deficits, and despite a boom of food yield as shown above, there are still striking differences in food consumption at the beginning of the 21st century, as shown in the next slide. On these slides, the balls drawn show you what are the today's averages of food availability in total kilocalorie per capita. It's almost 4,000 per day in OECD, but less than 2,500 in sub-Saharan Africa. These averages are problematic in both regions. In Africa, we are well below the level of 3,000, under which, according to the FAO, there is a higher probability of having people suffering from hunger. In OECD, we are well above what human well-being really need and ingest, which is between 2,000 and 2,500 kilocalories a day, depending on age, sex, size, and physical activity. Here, we have in fact an important waste of food, which is also a waste of fertilizer, water, pesticide, fossil fuel, and of all other rare resources used to produce and process food. Moreover, in OECD country, you can see that about 1,200 kilocalories out of 4,000 are today provided by animals, that is to say in the form of milk, meat, and eggs. Such a high consumption level of animal food may not be so good for health as many studies suggested, while in Africa and Asia, poor families would certainly enjoy consuming more milk, meat, and eggs. Besides, according to our own calculation, OECD countries use today about 3 kilocalories of plant food, such as cereal or oilseeds, to produce 1 kilocalorie of animal food. In other words, the 1,200 kilocalories of animal food in OECD represent 3 times more kilocalories in plant food equivalent, and therefore as much water, fertilizers, and pesticides to produce these crops. What about tomorrow? Are the past trends that you have seen before really sustainable? Socially, economically, environmentally. Past yield increase helped to save forests and to provide cheap calories to a vast majority of people. But it did not solve malnutrition and seriously threaten ecosystem services. In many parts of the world, we observe erosion of biodiversity, of soil fertility, groundwater depletion, pollution by nitrates and pesticides, etc. The modern agriculture of the past 50 years relies also on a massive use of non-renewable resources such as fossil fuel, phosphate, and potassium, whose price will be much higher in the decade to come. Second point, motorization boosted labor productivity and food surpluses of some countries. But how can the billion of very small-scale farmers concentrated in Asia and Africa escape from poverty? How can they produce more and more diversified food for themselves, as well as for urban citizens, which now represent more than half of the world population? What will be the economic and population growth in these developing countries? Will there be huge local as well as international migration due to poverty? Will there be, what additional production of plant food is required to meet the increasing demand for eggs, meat, and milk? Will we have enough land to produce this food, but also agrofuel, fibers, rubber, and many other non-food products? Can agriculture and agro-industries release less methane, nitrous oxide, and carbon dioxide into the atmosphere while preserving carbon and biodiversity pool in forest and pasture land? What will be the impact of climate change on agriculture and international trade? All these future uncertainties and challenges have been subject of hot discussion during more than 2 years within our Agrimonde group. From this discussion emerged 2 scenarios, 2 visions of food and agriculture in 2050.